Rather than talk in the abstract, I've decided to get the job up on the screen in OpenOffice. That's the word processor that I'm using to show you the codes that I've actually put into the paragraph indent, and I just told it that I want a space of 27 units for my paragraph indent. The computer works out exactly what's necessary to create 27 spaces. In the case of this layout, which is Kennerly 268, there's a 20 unit, but there is not a 7 unit, so the machine automatically stopped and changed the width of a 9 unit down to a 7 unit so it could get 27 units for me at the beginning of the paragraph. As I say, all the calculations were done automatically. I just told it what I wanted it, and the computer figured out how to accomplish. That you might see on the screen, the P here ends a paragraph, and the machine will attempt to justify that line if it can. The QO, which is right here, tells it to quad out. The code right here is italic, and the code right here tells it to make that line flush to the right. Here's a cancellation of the italic, and this whole rest of this line is quadded out, but since the right code is still in effect, it will be quadded to the right, in other words, flush to the right. And we're going back to justification here, and that's why the code is there. So those are some of the codes that have been entered into the job to make the Monotype. The first thing to be aware of is the fact that the Monotype machine changes the width of the character on the left-hand side of the letter, not the right-hand side. If it were the right-hand side, this W would be changed in width, but we don't want to change the left-hand side of the W, and therefore what we do is cast the W as normal, and then we put a code in here. In this case, it's L-2, which takes 2 units off the width. It's not taking 2 units off the width of the W, it's taking 2 units off the width of the Y. And this code cancels that, so that's L-2 with a slash in front of it, which cancels the code right here. And so it casts the Y only 2 units narrow. If I made a mistake, the whole word Wyoming would be cast at narrow width if I didn't cancel the code. Here's another W-E, we, and so we tuck the E underneath the W. Same deal, the L-2 at the beginning of the E, and then canceling with the slash L-2 there. That closes it off. Another example, and another example, which we will show you in a moment in the actual cast type. One other important thing to note is that spatial ligatures like ST and CT, here's the word justify. You see in the text that's in the word processor, I have done nothing on the ST, and I've done nothing on the ST over here either. Okay, I'll show you in a moment how Welliver's program takes care of that. Or Kennerly with italic and small caps, and I'll scroll down now, and this is the actual arrangement of the mat case. The FS stands for a fixed space, the JS stands for a justification space, and you notice we're working with a 6-unit row here, so the justification space is a normal setup. This is a spatial S127 wedge, which is indicated there over at the side just fine. And I want to talk to you about spatial characters, such as CT and the diphthongs AE and OE, the FF ligature. You notice that you got the FF type there. The computer, there's a FI in italic right there. There's a CT in italic and the ST in italic. There's the ST in Roman. I literally typed ST. I'll see if I can get that up on the screen so you can see it. Ah, great, it's fine. It says it's an ST. I just typed ST. I said it's a Roman font, and the activator is an ST combination, and the unit width of that character is 13 units, which is the width of the row that it's in there, and so it's okay. So that's all the information entered in there. If I wanted an AE or an OE, I would type AE. If I had a SP, for instance, in the italic, I would just simply type it in. This matrix case arrangement filters all the text going into the Monotype machine. And if the matrix case arrangement has an FFI ligature in it right there, if you call for it in your text, it will make the substitution automatically. You don't have to do a thing in the word processing program to get that. There's a 1/4 for a quarter and 3/8 and 1/8. I just type those, and if the manuscript has a 1/8 in there, it automatically, the Welliver program automatically makes the substitution to give you the 1/8 character out of the 15th row in this position. So that makes keyboarding and working with a manuscript a whole lot easier. You just put in the mat case what you have there, and the machine automatically. Here you see that I'm setting up the Macintosh computer to generate the ribbon. I gave it a file name and I just put garbage in there, but I'm telling it that I'm using Kennerly 268, which I've already created a mat case arrangement for. The system knows that the S127 wedge is supposed to be used, but I have keyboarded in that it's 11 1/4 set. It's 12-point type. I've keyboarded in that it's going to be a 20 pica line length. I'm not really concerned about page length at this time. I don't think that's totally functional in Bill's program. But that being said, now what I'm going to do is just go right down here and select the file that I want to use. And the file that I want to use is a Teeter print exe. And there's the file. Now I'm going to tell his program to justify the job. In other words, prepare it as it's supposed to be set. What you see here is a visual representation of what the job's going to look like coming out of the composition caster. You notice first of all that the gray area represents the set width of the characters. Bill has used a standard sans serif font, and he does not make an attempt to make the letters the width that they are in, but the gray block represents the width of those characters added together. The orange that you see is the width of the space between the words and the line, and over here are the justification codes that you would have had to enter if you were working at the keyboard. You notice that the E is blue with a line over top of it. That means that the set width has been changed, and that's exactly what we did in the keyboarding itself. The pink here is the spacing that I put in to indent for the paragraph. The pink here is the spacing the computer put in to end the paragraph. And there's a VE for veteran. The E, again, the set width has been changed. And so that's an indication to you that something has been done to the character. And so that's what the job looks like. If you see an excessive amount of space between words like you see here, you could go back and force it to do some hyphenation, or you could actually rewrite your manuscript if necessary. Okay, I told you about the ligatures. There's the word stash. And you notice it's underlined. The underlining tells you that it's going to be using the special ST character rather than an S and a T. And there's a Y, which is in dark blue overscored, and that means that the character's set width has been changed. And so that's the way the job looks like on the screen. Over here at the left is the line number 27. This is line number 28. And since the machine runs backwards, it also gives you the reverse count. So this is starting, this is the first line will be cast as right here at line 1, but there are actually 49 lines in the job. And so up here it becomes line 49 and line 1. That's what the job looks like. And at this stage of the game, you tell the machine that you want it to generate a ribbon, and what it does there is create a file which tells the composition caster exactly how to operate. I will now demonstrate that file. You see here that the name of the file that I want to use is called Teeter-type rib. RIB stands for ribbon. And I'm going to open that file. And there it is. Let's see. Okay. It's nice and big so you can read it. The name of the file is Teeter-type. It names the face that's being used. It names the set width for the wedge, which wedge is being used, what point size mold, and the line length. And then it just gives the codes as they go to the caster. This is to set the wedges, and this is setting the character. The position is 15-0, which is a quad, and it's quadding the end of that line out. And so it goes down through there, and finally it gets to some spaces. 13I is the position in the mat case, and in this particular arrangement, it's the capital H. I cast some H's so that I can get alignment set. This is the end of the line, the settings for the justification wedges for the next line, and we're typing some sorts now, I believe. Yeah, I'm typing some ST characters, and that gives it's a 11F in the mat case, and it is an FT character, and that's a space right there. And it keeps going. The CTs, the F5. I was casting sorts just so I could make corrections. Same with the alphabet. As scrolling down until we actually get to the real job. The stepping mechanism on the caster tells it when to send another character. NDEVELOP, develop. Okay, that's the way the text is actually sent to the casting machine. And that was generated by Bill's program after you got the visual representation on the screen of what you wanted the finished job to look like. Then the last step in Bill's program is to generate this file, which drives the casting machine. Here's a galley full of type that's come off the interface and off the composition caster, and I have this 36-point slug here to give you an indication of what the real beauty of the material coming off the machine with the interface. This is the justification of the lines, and throughout the job it's just as consistent as can be. The lines are all the right. Of course, I've got the caster machine itself properly calibrated, but generally running the machine, if you have kill lines, the mold gets cold and the line ends up being a little bit longer and a little bit shorter if it gets a little bit too hot and all that. When you're running the interface, it's one line after another with no halts, and so it's a consistent temperature, and if everything is right, you get a galley full of type looking like this. It's really fantastic. I've got a very unlikely combination here that needs occurring, and it's a WY for Wyoming. Okay, the W is cast to its normal width. But I don't know whether you can see it or not, but here's a Y, and the Y has been cast to a width that is much narrower by 2 units. And it is, as you see it right there, and as a consequence, the Y hangs over or overlaps the W. And so it goes together as a good combination, and therefore that's automatic kerning. As I can say, that is done at the codes in there, and the casting machine takes care of all the calculations necessary to cause this to happen. Here are 2 more cases of the kerning, automatic kerning. The T and the E in Terra Alta. The T is cast to the normal width. You notice when I pull it up, the E comes with it. That is because the E has been cast on a set width which is 2 units narrow, and the edge of the E right there is now overlapping the body of the T. Same is true in West Virginia. See, the E came up with the W, and that's because the E is cast to a narrower width. And so those 2 characters are automatically, or those 2 instances, we've got automatic kerning, and the line did justify just fine. And there's your WY for Wyoming there that we mentioned earlier. And so throughout the keyboard, throughout the manuscript, when you want kerning, you just do it. All you have to do is put 2 codes in the line where you want the kerning to take place.